Hey guys, this is Tom with MotorGo support. Today we're going to show you how you can download files from our printables account and configure a motor so that it's ready to spin within the MotorGo ecosystem. Specifically, we're going to show you how to put a magnet into the motor so that it can be read by an encoder, how to assemble the motor with our standard encoder mount, and how to put that entire assembly into your first robot to get a motor spinning. Alright, so now what you see is my computer screen, and I'm going to start walking you through where you can find our standard content library on Instructables.com. And I can just search for MotorGo LLC. So if I click on MotorGo LLC and go to 3D models, I can see everything that we've posted on printables. So you have a couple of projects and then several smaller things that are more meant for test stand type work. So I'll go into the MotorGo test stand page, where now I can see the MotorGo PTZ2804 motor mount. On this product page, or on this page, you've got an exploded view of how the assembly is supposed to look. You've also got a couple of assembly views to show you the finished product. This green square here is an EncoderGo, which is just our own encoder. It's a very high resolution encoder, and it plugs really easily into the MotorGo. All we need to do is go to the file section. We could download the step files. This is more for if you wanted to do custom modifications to any of the designs. But since we're just going to download and print, all I need to do is find the STLs. I'll just go over here and click download on the magnet holder first. And yes, I want to allow downloads from printables.com. There we go. So now we're starting to download, and I'll go ahead and download the rest of the files as well. Okay, so I've downloaded a magnet holder, a retainer cap, a retainer rail, and a motor mount. There's two more things that I want here. So I want a small test stand base, and this is basically a pegboard that you can bolt any motor mount to, and I'll just go ahead and download that, and all I want is the STL. And then I will also go back and download a little mount for the MotorGo PCB. It's just a convenient little mount to keep it from falling all over the place. So I'll go to Files, and then download, again, only the STL, because we're not doing any custom modifications, so we don't need the step file. So that should be everything that I need in order to make this project work. What I'm going to do now is I'm going to take these downloads and I'm going to open up my 3D printer software. We have a Bamboo at home. It's a fantastic printer if you're looking for one. And yeah, so what we're going to do is I'm going to drag and drop these STLs into Bamboo Slicer. There's a few things that I want to do here to get it ready to print. First of all, I don't want them printing all over each other because that would be kind of silly. But there's also a way to orient these that's best for minimizing the amount of support needed and maximizing the quality of the print. Specifically for the test stand base, what I'm going to do is I'm going to auto orient it so that its face is down. I'm going to kind of move it out of the way there. And then I'm going to start moving these pieces around, reorient this one too. And typically for motor mounts, I like to print them face down like this. And that's because the support messes with it the least in this orientation, and the quality tends to be kind of as good as it'll get. For this retainer cap, you can see that it's also a little funky looking. That's not an ideal print position, so I'm going to auto orient that one. And then for the magnet holder, I'm also going to orient it there. Now we've got everything pretty much laid out in the right orientation, but they're also still kind of all over each other. So I'm going to auto arrange all of the objects, and now you can see these are all laid out nicely and should print just fine. Alright, so we have a few more things to cover before we're ready to send the print to the printer. Primarily, we were notified by Bamboo Labs that the sparse infill pattern, the default grid, causes some quality issues in the print. So what we want to do is change that to gyroid. Gyroid is a consistently high quality, it's pretty much a winner for most applications. So we're going to gyroid print, and we're going to change the sparse infill density to 10% because we don't need these to be that crazy strong. The other thing we're going to do is we're going to enable support, but we're only going to do normal support manually because there's one part that I need supported, and that is the motor mount. You can see these 90-degree angles would have some quality issues if they were not supported, so we're going to do that. In the Bamboo Slicer, the way that works is you simply select a part and go to the support painting tool, kind of flip it over there, and then I'm going to use the fill tool and try to just get this face right here. Turn green, that indicates to me that it is going to be supported by the slicer, and then I can back out of there just by clicking away from it, and now we should be gangbusters. To recap, I went through and changed the infill pattern to gyroid, the infill density to 10%, and then I added a manual support on the motor mount to make sure that it would print with acceptable quality. With all of that said, I'm going to slice the plate and see how it does. It takes a minute because my MacBook is a little slow sometimes, especially when it's doing stuff like this, but I think it'll survive. Okay, so let's take a look here. That green indicates that there's a support on the motor mount. The only thing I want to make sure is that there's no support inside of this itty bitty magnet holder. If the printer fills this in with support, then we'll be kind of out of luck with that part as it's hard to get it out. All right, well this looks great. Everything is sliced, we've got the support where we want it, and it's all laid out. Looks like it'll print just fine. You can see here, Bamboo will estimate how much filament you'll use, about 70 grams, and it'll take about 2 hours and 43 minutes to finish the print. So that's fine with me. I'm going to go ahead and hit print plate and go into configuring it. I'm going to choose a white PLA for this, just because it'll make it pop in the video a little bit more. And I'm going to send it to King Bamboo, which I challenge you to top as far as naming your printer goes. That's all there is to it. We've got about 70 grams print, 2 hours 43 minutes, and A4 white PLA for all of these parts. So I'm going to send that, and I will cut to a time lapse. All right, so that print was successful. We've got the receiver rail, motor mount, PCB mount, retainer cap, magnet holder, and test stand here. All these parts printed great on the Bamboo, and so we're almost ready to assemble everything. I'm going to start with the motor first because it's more fun, then we'll do the heat set inserts, then we'll be ready to put everything together. And now we've got the magnet holder, we've got the motor, got an encoder magnet here, which is pretty small, and we've got a bit of super glue. So first thing is you've got this itty bitty hole here. And the encoder magnet we have is diametrically magnetized, and it's 3 millimeters in diameter. So it fits that hole pretty good. The way it's been printing on the Bamboo, the tolerance I gave it makes it a nice little press fit. So you just kind of stick it in there, get it started, and then you can sort of smush it down, and it should pop out just a little bit. That's what it shows in the CAD, and it looks like it's a good fit there. You can also add just a very small amount of super glue to this if you want to make sure that it stays there forever. But a press fit, it's been pretty good for us in the testing that we've done. So that's up to you. So what we want to do is just stick this guy in here. The way this is designed now is it's a nice, pretty loose fit. So it should be very easy for you to get in there. So all you're going to do is you're going to take a little bit of super glue and dab on there a drop, maybe a drop on each side. And then you're going to just slip it in there like that, let it dry. And that's all there is to the magnet installation. So now we're going to do the first heat set insert on the receiver rail. A quick note on these inserts. This is just the kind that we got. You can see the bottom side has this little circle profile to it, and the top side's got that spiked profile that'll give it traction in the PLA. So when we install these, we want this bottom section, or this circular section, to be facing the bottom. That'll make it work the best and look the nicest. What I'm going to do is set this receiver rail here, and then I'm going to grab our soldering iron, and this guy is set to just under 200 degrees. If you look at PLA print settings, you don't want to exceed that by too much. So what you want it to look like is more like that. So you've got that circular side going down, and you're going to let it kind of just melt its way on in there. And you can see it's moving pretty quick. You want to double check the profile, but that looks okay to me. I might give it a little bit more. And that is the first one. So now we're just going to flip it over. Just to show you again, that's what it looks like on the soldering iron. And then just pop it right in there. Cool, so that one's done. And now we're going to do the motor mount inserts. So this one is very similar to what we did in the past. We're going to just take these two holes, which are designed for M2 heat set inserts. We're going to do the exact same thing that we just did. So this is the M2. You can see that's a lot smaller, but it is the exact same idea. And you want to be careful when you're doing this not to pull too much to one side or give it an angle, because it's a very hot piece of metal and it is able to melt the PLA, so if you deform it too much, then it won't be where you put the hole. And now we are ready to assemble the whole thing. Alright, so first we're going to assemble the motor mount. What we have here is an EncoderGo. This is sold by the MotorGo company, and it is a very simple PCB with a 14-bit encoder on this side and a JST connector on that side. So you just slap that on the back. It can read any magnet that you want to read. The other thing that I'm going to point out is this is that motor that I mentioned earlier. And, oops, chaos. What we also have is the motor that I mentioned earlier that I've already assembled, and full disclosure, I don't have the necessary adapter yet for this connector. So I went ahead and soldered leads onto a DuPont connector, which is what we're going to use to connect to the MotorGo. So all you need to do is pass the wire through that hole. You want to make sure you've got it lined up there like that. And it's getting pretty close to looking aligned. What we'll do next is we'll take one of these bolts and we will bolt it down. As I'm doing that, I'm going to mention that if your bolt is too long, you can just drill right down until you destroy the windings. And I've done that a time or two. So just something to be aware of. Typically about 2 millimeters of difference between the bolt length and the thickness of your motor mount is a good practice to stick with. So now the motor is installed onto the front of the motor mount. It's bolted down nice and snug, and the wire has a clear path away from the magnet mount. So the next thing we're going to do is we're going to install the encoder. Basically, you have a little bit of gap between the motor mount and the encoder because of these notches, so you can feed the wire directly through there. When you do that, you just want to make sure that this little black thing here, that's your encoder. You want to make sure that that guy is facing down, and that's really the only requirement here. So then you use these really endearing and cute M2 bolts that are impossible to lose in the carpet. Drop that in. And that is all there is to it. Now you have a fully assembled motor mount with a now encoded motor. Good job, you. Alright, so we're almost at the finish line, and now I'm going to plug in the MotorGo and write code to it. See, lights up, means he's happy. Now I'm going to open our Arduino IDE. All we really need to do to get started is select the right board and select an example sketch. So under boards, I'm going to type in motor, and what you'll see is we've got 3 MotorGos here on the Arduino IDE. What I'm using today is V1 Rev 2, so I'm going to go ahead and click that one. And just because I'm a really smart guy, I already know that this is the serial port that is connected to that MotorGo. Actually, just to prove it to you, I'll disconnect it. You'll see how that disappears. When I plug it back in, it'll pop back up. So that's a good way to test and make sure that you're using the right serial terminal. So go ahead and click that, click the board, and then click OK. So now what I need to do is go to File and Examples, and all the way down at the bottom, because we've already installed the MotorGo Mini driver with example code, I've got a bunch of examples. For this video, I'm going to click the spin 2 motors example. The code that can spin 2 motors will also just spin 1 motor. There's no errors or issues with the board by doing that, and this just makes it a little bit easier for us. At a very high level, this is a bunch of setup stuff. This is also a bunch of setup stuff. And the only thing we're going to cover today is specifically around calibrate. Because we've never used this combination of motor, magnet, and encoder before, we need to calibrate the magnet to the encoder. Basically what that's going to look like is this motor here is going to spin very slowly in both directions and give the encoder a chance to map the magnetic field to the positions that it sees. Other than that, I'm going to quickly edit some PID parameters here. Again, we'll cover this in more detail later, but just know that for now, me changing that number is going to make the motor spin a little smoother. After that, we go down to our loop, just setting target velocities and printing out the velocity that we measure. Without further ado, I'm going to go ahead and upload the sketch. Now what you're seeing is the motor is calibrating itself with the encoder. The nice thing is, if you have a motor mount assembly and you don't change the board you're using, you only have to do this calibration once. The board will save the calibration whether you reboot it or change the program, as long as you don't change the pin position of the motor, change the encoder, or change the magnet or something like that. You can basically calibrate it once and it will stay calibrated as long as those things stay constant. And now we are spinning. That's the end of this video. Your first robot, this is technically a robot, has been completed and you've done it. Great work. Thank you for hanging in there, and we look forward to seeing you next time.